For decades, scientists believed the moon formed slowly, from molten debris coalescing over months, perhaps even years, after a cataclysmic collision between Earth and a Mars-sized body. But a groundbreaking new supercomputer simulation is turning that idea on its head. According to this ultra-high-resolution model, the moon may have formed not over millennia, but in just a matter of hours. The simulation, one of the most detailed ever constructed, begins with a scenario known as the giant impact hypothesis. A massive protoplanet, often referred to as Theia, slams into the early Earth. The impact is unimaginably violent, sending colossal plumes of vaporized rock and molten metal into orbit. But here's where the new model changes everything. Rather than a slow aggregation of particles, the debris from the impact rapidly splits into two major bodies. The larger one becomes a newly reformed Earth. But the smaller? That becomes our moon. And instead of gradually settling into orbit, it's flung outward, stabilized almost immediately by the gravitational force of the larger remnant. This dynamic launch places the moon on a wide, stable orbit that persists to this day. This bold reimagining of lunar genesis helps solve a long-standing mystery: why the moon's composition is so eerily similar to Earth's. If the moon had formed primarily from Theia's material, we'd expect major chemical differences. But if Earth and moon split almost simultaneously from the same molten mass, as this simulation shows, it makes perfect sense that they would share the same isotopic fingerprint. And the implications don't stop there. Researchers suggest this model could help explain other features of the Earth-Moon system, from tidal locking to the inclination of the moon's orbit, to the strange asymmetry between its near and far sides. It might also shed light on how other planetary moons formed, especially in chaotic early solar systems. To achieve this insight, scientists relied on a new generation of supercomputers capable of handling over 100 times the resolution of previous lunar simulations. The higher detail allowed them to accurately simulate not just the overall dynamics of the collision, but the thermal evolution, angular momentum, and internal differentiation of the resulting bodies. It's a thrilling reminder of how far our tools have come, and how much mystery still remains in the sky above us. This new model doesn't just answer old questions, it invites new ones. What if our moon is not an ancient relic slowly pieced together, but a survivor of a cosmic firestorm, born in the span of a single day? If true, the moon's existence becomes even more extraordinary. Not the slow child of planetary evolution, but a phoenix risen in an instant from the ashes of planetary destruction.